Hello, good evening, madam. Madam, can you make me host? Yes, students. So in the last class, we have solved the problems on Einstein's photoelectric equation. Now, let us take up some few MCQs on the power and the number of photons in the radiation of given particular wavelength or the frequency. So let me solve the concepts based on the number of photons and about the power. Look at this question. The number of photons of wavelength 540 nanometer. So lambda is given. 540 nanometer. That is emitted per second by an electric bulb of power. Per second they are talking. So time you can take it as 1 second. What is the power of the bulb? 100 watts. Now you just have to find the number of photons. Yeah. What's the formula for the power? Power is nothing but energy divided by the time. Now, you know that the energy associated in one photon is hc by lambda. For n number of photons, you have to denote with n. Correct? No? Yes. So power is equal to energy associated with n number of photons is given by n times of hc by lambda into t. They are expecting you to find the number of photons, isn't it? Yeah. How to find the number of photons from this? Number of photons is power lambda into t whole thing divided by h into c. Now, can you substitute the value of this? Power lambda t h value and c value. So n is equal to, power is how much? 100. What about lambda? 540 nano. Nano means 10 power minus 9. Time is 1 divided by h, 6.6. Or they have given h value as 6 approximately. So you can take out only 6. You can take out 6 into 10 power minus 34 into c value 3 into 10 power 8. So what will be n? Now 6 ones are 6 nines are 3 ones are 3 threes are. So left out is only 3. Look at the power. Look at the power. In the numerator, we have 1 0, 2 0, here 1 0, 3 zeros. So 10 power 3 into 10 power minus 9. So in the numerator, we'll have 10 power minus 6. If I take 8 to the numerator, it becomes minus 8. So minus 6 minus 8 will be minus 14. If I take minus 34 to the numerator, it becomes plus 34. So minus 14 plus 34 will be 10 power 20. So what is the number of photons emitting per second with this wavelength 540 nanometer and with 100 watt power? With 100 watt power and 540 nanometer, the number of photons associated is 3 into 10 power 20. So which is the right option? Option C. So this is the number of photons which is emitting per second. So this is the number of photons. This is the number of photons emitted per second, because in 1 second they have given this. So per second, number of photons emitted per second is 3 into 10 power 20. I hope you got it. Yes. Come to this problem. There is a steel ball of mass. What is the steel ball mass? 1 kg. This is moving with a velocity of how much? 1 meter per second. Then what is the de Broglie wavelength associated with? Actually, what is the de Broglie wavelength formula? Lambda is equal to h divided by mv. Now, can you tell me what is this lambda value? What is lambda value? Don't substitute the value of h, because options are in terms of h. So I'll keep it as h only. What is mass and velocity? 1 into 1. What is lambda then? H by 1. H by 1 is nothing but h, no? So lambda is equal to h. So what is the de Broglie wavelength for this steel ball of mass 1 kg moving with 1 meter per second? Lambda equals to h. But please remember, actually this can't be considered as a de Broglie wavelength, because you know that the de Broglie waves are associated with the moving particles like electron, proton, alpha particle. Why this is not possible? Because you know the value of h, right? Only the power at least. H value is 6 point something, that is 6.625 into 10 power what? Minus 34 meter. Look at this number, my dear. 10 power minus 34 meter, which is a very small value. 10 power minus 34 means 0.0000. How many zeros? 33 zeros followed by 1. This is 33 zeros. Imagine this number, which is a very small number. So we cannot find the wavelength of that particle. Because of this reason only, in order to reduce this 10 power minus 34 to angstrom, we have considered a very small mass. If this mass is very small, then if I substitute the electron mass or proton mass like that, it will go with the 10 power minus 27, 10 power minus 31. If I divide this number by 10 power minus 31 or 10 power minus 27, then this approximately comes out to be like 10 power minus 7 meter, which can be an appreciable value. So in order to come the wavelength to angstrom or nano or 10 power minus 7, you have to consider the particles like electron, proton, alpha particle, where the mass of these particles is very small or a less value. Because of that reason only, we are going to find the de Broglie wavelength for a very minute small particles, not with any huge body masses like 1 kg like that. So please remember, de Broglie should be always associated with moving particles like electron, proton, not with huge bodies. If you find the de Broglie wavelength for the huge bodies, it is going to be a very negligible, like 10 power minus 34 meter. This is the reason why we are considering only the subatomic particles like electron, proton, and alpha particle. I hope you got this concept. Yeah. Yes. Come to this. The de Broglie wavelength. The de Broglie wavelength associated with hydrogen atom. Hydrogen atom means 1H1, no. How many protons it contains? 1 proton. Hydrogen contains how many protons? 1 proton. What is mass of the proton? 1.67 into 10 power minus 27 kg. 1.67 into 10 power minus 27 kg. Yeah. This proton is moving with what velocity? It is moving with the velocity of how much? 3 kilometer per second. 3 kilometer per second. You have to find what is the de Broglie wavelength. Yeah. What is de Broglie wavelength formula, pa? Lambda is equal to h divided by mv. Yes. What is h value? 6.625 into 10 power minus 34. Mass value is 1.67. Velocity is 3 kilometer per second. So what is 6.6 by 3? It is 2.2 divided by 1.6 into 10 power minus 27 plus 3 is minus 24. When this 10 power minus 24 goes up, it becomes 10 power plus 24. So minus 34 plus 24 will be minus 10. So lambda equals to 2.2 by 1.6. It is approximately equal to 1 point something into 10 power minus 10. So this is approximately, I can take it as 1 angstrom. So which is the right option? Option E. Approximately, you can consider that as one angstroms. But actually, they have not given accurately about this thing. Let me go with another method. For that, let me check whether you will get the accurate value or not. What is that? Now, instead of calculating for this thermal velocity, actually, if you calculate for this thermal velocity, you will find it as 1 point something. But actually, there is don't have the option like 1, which is also close to 0.66 also we have. So let me try with another velocity. I hope you have studied about the concept of RMS velocity, right? Let me check for that. Let me check for that. But you have to remember that RMS velocity of the particle is always twice the thermal velocity. RMS value of the particle velocity is twice the thermal velocity. Now, for this, you can substitute lambda is equal to h divided by 2 times of m into that thermal velocity. So you have to just divide by what? 2 for this case. This is for with respect to RMS. This is with respect to thermal velocity. So what is 2.2 divided by 1.6 accurately? It is 1.1 divided by 0.8, that is 11 by 8. This is approximately equal to 11 by 8. What is 11 by 8? 1 point, remainder will be 3. So 8, 3s are 24. So approximately you can take 1.3. So this is 1.3 angstrom. Accurately it is 1.3. Now if I divide that 1.3 by 2, I have to divide this by 2. So you're going to get RMS wavelength as 1.3 by 2. 1.3 by 2 is nothing but 0.65 angstrom. So that is also there here. 0.66 angstrom. So please be careful. 0.66 angstrom you are going to get for which speed? For RMS speed. Approximately you will get almost like 1.3 angstrom for thermal velocity. So what is the de Broglie wavelength with respect to thermal velocity? 1.3 angstrom. With respect to RMS speed, you are going to get 0.66 angstrom. Both the chances are there because options are not accurately mentioned here. But actually, strictly speaking, as per the question, you have to go for 1.3 angstrom only because they are asking to find the de Broglie wavelength for this thermal velocity only. So both the chances are there. Yeah. Come to this. when the momentum of a proton is changed by an amount P naught. Momentum of the proton is changed by the amount P naught. Then they are expecting you to find the corresponding change in the de Broglie wavelength. That is found to be 0.25%. They are asking you to find what is the original momentum. They are asking you to find what is the original momentum. What is the change in momentum they have given? Change in momentum is given P naught. Change in momentum is given by P naught. They are asking you to find the corresponding change in the de Broglie wavelength. Corresponding change in the corresponding change in the de Broglie wavelength is given. How much? 0.25%. So that is delta lambda by lambda. Percentage change in wavelength divided by the original wavelength, that is 0.25% is given. Now they are expecting you to find the original momentum of the proton. Assume P is the original momentum of the proton. Let P equals to what? The original momentum of the proton. Yeah. You know that the wavelength and the momentum, how they are related. Lambda is equal to H divided by P. Lambda is equal to H divided by P. Now, lambda is equal to or is proportional to P power minus 1. Now, according to your absolute error, which you have studied in the 11th standard, like this you have studied, right? Z is equal to A power X. What is the error in Z? Delta Z by Z is equal to how many times? X times of error in A. Only the magnitude you are talking. We are not talking about this. This only tells that if the wavelength decreases, the momentum will increases because they are inversely proportional. So what is the power here? 1. So what is the change in the wavelength? 1 times of the change in the momentum. But please remember, I am talking only the magnitude, my dear. If wavelength is decreased, momentum will increase. If wavelength increases, momentum will decrease. That will take ulta. Momentum and the wavelength. Yeah. What is this delta lambda by lambda they have given? It is 0.25%. 0.25%. Percent means what? By 100. Delta P is the change in momentum, right? What is the change in momentum value they have given? P naught by P. By P. Cross multiply. What is P? 100 times of P naught divided by 0.25. That is equal to 0.25 can be taken as 1 by 4. So 4 goes up. So 400 P naught. So what is the original momentum? Original momentum will be 400 times of P naught. 400 times of P naught. So which is the right option? 400 P naught. Option C. The same problem can be related like this, Appa. They will give in the another different forms. Let me explain that. I will find the space. Yeah. I'll try to explain it here. Like this. Now, the related to that. If momentum is increased by 4%. If momentum is increased by 4%, can you tell me by what percentage the wavelength has decreased? The wavelength has to decrease, right? Because the momentum and the wavelength are inversely proportional, right? If the momentum is increased, the wavelength has to decrease. If the momentum is increased by 4%, if the momentum has increased by 4%, can you tell me by what percentage the wavelength has decreased? Use the same concept. Lambda is directly proportional to p power minus 1. What is the percentage change in the wavelength? Minus 1 times of delta p by p. Momentum increased by 4%. So 4% into minus 1, minus 4%. This minus sign tells the wavelength has decreased. So if the momentum is increased by 4%, wavelength also decreases by 4%. Decreases by 4%. Look at this. If kinetic energy is increased by 4%, how the wavelength is going to change? How the wavelength is going to change? Can you tell me how the wavelength and the kinetic energy are related? You know that wavelength is equal to h by p. You know that momentum can also be taken as root of 2 m ek. So that clearly tells wavelength is inversely proportional to root of ek. Or I can take ek power of can be taken as whole power. Root can be taken as whole power of. When it comes to numerator, it becomes minus of. So can you tell me what is the change in the wavelength then? It is minus of times of change in kinetic energy to the initial. So minus 1 by 2 times of. What is change in kinetic energy to the original kinetic energy? Changes by 4%. So 4% by 2 will be 2% minus. So the wavelength has decreased by how much? 2%. Half of this. Look at the difference. Look at the difference. In the case of the momentum, if the momentum is increased by 4%, the wavelength also decreases by the same value, that is 4%. But if the kinetic energy increases by 4%, the wavelength has to increase by how much? 2%. So this is what you have studied the concept like an relative error, percentage error, like that in the 11th standard. Yeah. Now my question is, Now my question is, suppose if kinetic energy is increased by 300%, if kinetic energy is increased by 300%, can you find what is the change in the wavelength? Huh? If kinetic energy is increased by 300%, can you tell me the percentage increase in the wavelength? Any idea or any guess? We cannot make use of this method. Please remember, we cannot apply this method for this case. Why, sir? Why? Because this, whatever the formula we are writing here, that is relative error, this is applicable only for a small percentage. It is applicable only for a small percentage. So absolute error, relative error is applicable only for the small percentage values. Hello. If it is a very large percentage, we cannot apply this particular method. Be careful. Then what you have to do, sir? Yeah, assume. If you take the initial energy as E, what will be the final energy? It is increased by 300%. So 300% means it has increased by 3 times, right? So it becomes 4E. So final energy will be 4E. It is increased by 300 times, 300% times. That is 3 times. Now, how to calculate the percentage change in wavelength? Change in wavelength, that is lambda initial minus lambda final by lambda initial into 100 if you want in percentage. Now, this can be change in wavelength by the original wavelength. This can be taken as 1 minus final wavelength by initial wavelength. If you want in percentage, you can take it as 100%. I'll continue here. I'll keep 1 minus as it is. These wavelengths are inversely proportional to energy under the root, right? Lambda is inversely proportional to the root of energy. So lambda final by lambda initial can be taken as root of E initial by E final into 100%, which is equal to 1 minus. What is initial energy? E. Final energy is 4E. So E by 4E, E will get cancelled, 1 by 4 under the root. Root of 1 by 4 is how much? 1 by 2 into 100%. 1 by 1 minus 1 by 2 will be off. Off into 100% will be equal to how much? 50%. So the wavelength has reduced by how much? 50%. So please remember this method, how we can apply for small percentage value and for large value of the percentage. This may be asked in any particular chapters, not only in the case of dual nature. Got it? You got the difference at least? Yeah. Come to this. there is a particle like electron. That electron particle is having the same momentum as that of the photon. What is the wavelength of that photon? 5200 angstrom. Then they are expecting you to find what is the velocity of the electron in terms of what? Meter per second. In terms of what? Meter per second. A very quite simple formula. Momentum is given as same. Momentum is given as the same. How to find the velocity of this electron in meter per second? What is the de Broglie wavelength? Lambda is equal to h divided by m into b. Mass into velocity. Now, can you tell me lambda is also equal to h by p? Or I can say momentum is h by lambda. What's the formula for momentum? H by lambda. Yeah. What's the given condition? Electron is having a same momentum as that of photon. Momentum of electron is equal to the momentum of the photon. What is momentum formula? H by lambda. So h by lambda of the electron. H divided by lambda of the photon. So this h and h will get cancelled. So this clearly tells, taking reciprocal, wavelength of the electron is equal to the wavelength of the photon. Since the momentums are same, please remember, if the momentums are same, the wavelength associated is also same. If they have the same momentum means, the wavelength is also same, right? So this is the wavelength of the photon actually, but you can take this as the wavelength of the electron also. If the momentum is same, wavelength are also equal. Wavelength are also equal. Therefore, if you want to find the velocity of the electron, then you have to consider the velocity of the electron. Because they're expecting you to find the velocity of the electron, right? So wavelength of the electron is equal to h divided by m into VE. VE is the velocity of the electron. So how to calculate the velocity of the electron? It is h divided by m into wavelength of the electron. What is h value? 6.6 into 10 power minus 34. What is the mass of the electron? You know that it is close to 9.1 into 10 power minus 31. Into wavelength of the electron can be taken as 5200 angstrom. Yeah. Can you simplify this further? This is approximately 3 times. This is 2.2 times. 2.2 by 3 is approximately equal to 0.7. Divided by, I will write only 52. I will carry these 2 zeros over here. Or even if you want, you can take it as 0.52 only. I'll shift all the 4 digits. So numerator 10 power minus 34 as it is. This 10 power minus 31 as it is. If I shift 1, 2, 3, 4 digit towards the right, it becomes 10 power minus 6. This 0.5 can be taken as 1 by 2, right? 0.52 can be taken as 1 by 2. So 1 by 2, so 2 goes up. So if 0.7 into 2, it becomes 1.4 into 10 power minus 31 minus 6 minus 37. When it comes to numerator, plus 37 minus 34. Minus 37 plus 34. I mean, reverse. Plus 37 minus 34. It will be 10 power 3. What's the unit for velocity? Meter per second. So which will be the right option? Option B. 1.4 into 10 power 3 meter per second. So which is the right option, Appa? Option B. Got it? Yeah. Come to this. De Broglie wavelength of the neutron. You know that neutron is a neutral charge. Neutron is a neutral charge. So you cannot write the formula directly as like lambda is equal to h by mv or h divided by root of 2 mqb. We cannot write like that. They have given this temperature 27 degrees Celsius or 927 degrees Celsius. Sir, how you can relate this de Broglie wavelength in terms of temperature? Yes. You know that de Broglie wavelength is given by the formula h divided by m into v. You know that mass into velocity is momentum. You know that the momentum can be written in terms of kinetic energy as root of 2m into ek. From the first view concept, you know that energy associated with each degrees of freedom is 3 by 2 times of kT, where this k is constant called the Boltzmann constant. What is that k called? Boltzmann constant. This is according to a law called law of equipartition of energy. Law of equipartition of energy. So according to the law of equipartition of energy, you can write the kinetic energy associated with each degrees of freedom as half times of kT. For monatomic in general, we can take it as 3 by 2 times of kT, because for monatomic, there will be 3 degrees of freedom. So total energy will become 3 by 2 kT by assuming it is for monatomic. So lambda will be equal to h divided by root of 3 times of m k into t. This 2 and 2 will get cancelled. Forget about these constants. How this wavelength and temperature are related. That is very important here. The wavelength is inversely proportional to square root of the temperature, isn't it? So can you tell me What is lambda 1 by lambda 2? It is root of T2 by T1. What is the first wavelength? Lambda. What about the second wavelength? You have to find divided by equals to root of T2 by T1. What is T2? What is T2? 927 degrees Celsius. But you have to convert into Kelvin, isn't it? Because capital T is there. Capital T means the SI unit of temperature is Kelvin. So convert that degree Celsius into Kelvin. 927 plus 273. 1200 Kelvin by. What is T1? 273 plus 27. 300 Kelvin. Two zeros will get cancelled out. So root of 12 by 3. Root 4. So root 4 is 2. So this implies lambda 2 is equal to lambda by 2. So what is the second wavelength lambda 2? Lambda by 2. Option A. Got it? So please remember this formula. How the de Broglie wavelength is related to the temperature for the neutron case. Lambda is inversely proportional to the root temperature. Yeah. Come to this. De Broglie wavelength of a vehicle is lambda. Load is changed. Load means the mass. In that, velocity and energy both are doubled. Velocity is doubled. Energy is also doubled. Initial wavelength is lambda. They are asking to find what is lambda dash. So, after putting the load, they have given the condition that the velocity and the energy both are doubled. Both velocity and energy both are doubled. Now they are asking you to find the new wavelength. Now, the logic behind this problem is just you have to bring the formula of the wavelength in terms of velocity and the energy. That is the important concept here. So why you have to bring the wavelength in terms of velocity and energy? Because in this problem, they are changing the velocity and energy only. And how the velocity and energy are changing? Both are doubled. Both are doubled. Then how the new wavelength is going to change? Yeah. Look at this concept. Lambda is equal to h divided by mv, right? Yeah. Now, can I write the same equation like this? Yeah. This v can be taken as v squared into in the numerator v. So just I'm multiplying and dividing by v. So in the numerator you will get v, in the denominator also v, so it becomes v square. And I will just multiply 2 and divide by 2 in the denominator. Can I do like this? Multiply and divide by V, numerator V, denominator V. In the denominator, you can multiply and divide by 2, like this. Why I am doing like this? Because you can take this half mv squared as what? Energy, no? Energy. So this clearly tells lambda is directly proportional to velocity and inversely proportional to energy. Wavelength is directly proportional to velocity and inversely proportional to energy. Wavelength is directly proportional to velocity and inversely proportional to energy. Now, what is lambda dash by lambda then? V dash by V. Since E is inversely proportional, it will be E by E dash. Now, V dash is doubled. So, 2V by V, it is 2. E dash is 2E. E will get cancelled. So, 1 by 2. So, 2 and 2 will get cancelled. That is equal to 1. So, this is equal to lambda dash by lambda. Or cross multiply. Lambda dash is equal to lambda. So even if you double both velocity and the energy, the wavelength will not change. The wavelength will remain same. The wavelength will remain same. So lambda dash is equal to lambda. So which is the right option? Option A, lambda. I hope you understood the concept of energy, velocity, and the wavelength. Yeah. Yes. Take up this last problem in dual nature. What is the minimum intensity that was detected by the human eye? Intensity I. 10 power minus 10 watt per meter square. What is the number of photons emitting with a wavelength? What wavelength? 5.6 into 10 power minus 7 meter. With a pupil area 10 power minus 6 meter square. They are asking with per second only. So time you can take it as 1 second. You have to find the number of photons. Yeah. How to find this? You know how to define the intensity. Intensity is power divided by area. What is power? Energy by the time. If there are n number of photons, n times. So n, E can be taken as hc by lambda because lambda is given, T into A. Now they are expecting you to find the number of photons. So this implies the number of photons n is equal to cross multiply intensity into T times of lambda into A divided by h into C. So n is equal to. Now you can substitute the values. You can substitute the values. What is intensity? 10 power minus 10. What about time? 1. What about lambda? 5.6 into 10 power minus 7. What about area? 10 power minus 6 divided by h value is 6.6 into 10 power minus 34. C value is 3 into 10 power 8, which is equal to, I will keep this 5.6, denominator 3 into 6.6. It is approximately close to 20. because 6.6 into 3 will be 19 point something. I will take that value as close to 20 into 10 power how much? Minus 10, minus 7, minus 6. How much it is? Minus 17, minus 6. Minus 17, minus 6, minus 23. Minus 23 when this 8 comes to numerator, minus 8. Minus 23, minus 8, minus 31. For minus 31, if I take plus 34, it will be 3. So 5.6 into 10 power 3 by 20, that is equal to 5660 divided by 20. This 2 1010 will get cancelled out. So approximately we'll get 560 divided by 2. Approximately I'm talking 560 divided by 2. So it is approximately, you can say 600 by 2. This value is approximately equal to how much? 300. So you can go with option C. You can go with option C. So this is how we are calculating the number of photons in the case of the intensity and the area. Yes. You have any doubt? Okay. So these are the problems based on the dual nature of radiation and the matter. So in the tomorrow's class, we will take up the new chapter, that is atoms. So totally we have left out with 3 chapters apart, that is atoms, nuclei and semiconductors. So in the tomorrow's class, I will start up with atoms. Thank you.